All right, so let's talk about SQL. Uh, so, so SQL as a stands for Structured Query Language. It was an attempt at bringing all this mathematical theory on set theory and all this research and actually implementing something that might actually be useful for the masses. And it was an attempt to to lower the bar of entry for folks to start actually using this. Right. So there was a lot of effort at making this easily readable, kind of like a pseudo English language that was hopefully self-explanatory of what is it that it was doing. So here's an example of it where you can say select fields from table. It's a very certainly it's based on the select algebra that we saw earlier, where you can kind of a combination of both projection, right, selecting what the fields are, right, and also selecting that you want fields from a particular table. So this allows you to filter the data in both vertical and also in horizontal, right, be able to choose what is that you want. Actually, no, this only allows you to select filter horizontally, right? Only the fields that you want. This would actually return all the records in the table, right? Additionally, there would be a where clause here where you can provide a predicate that allows you to then filter the records vertically, right? And then zone in on what actual data that you want. It allows you to provide a set of input tables, and then your SQL query returns a pseudo or temporary table that has a combination of the fields from the original tables and also a combination of the records from the original tables, right? And you can treat this just like a normal table. You can use this to feed into a even more complex query. Right? You can also use it to create temporary tables, actual tables, or virtual tables as well, as we'll see a little later. Right? That could answer some of the needs for different audiences. Right? We'll see that a little later. So here's the same example tables that we saw earlier. A very simple database for a university, a couple students, departments, courses, sections, enrollments. So let's take a look at using the SQL to answer a couple questions from this database. So here we have selecting students from the table of the data set. The student, I like to retrieve the student names and the graduation year. Notice that the fields are prepended with the name of the table. If there's only one table, the from clause allows you to specify multiple tables, right? Especially if you're doing, obviously, if you're doing a join. But if there's only one table, the prepending of the student in front of the field is unnecessary. It's implied that that's the fields you're getting it from that particular table. If indeed you have multiple tables, then it is necessary to add them. If the fields only appear in one of the tables, then it's not necessary to prepend it with the name of the table. It is implied. It can figure out on its own. But if you have fields that have the same name in multiple tables, then you have to add prepend it with the name of the table so that you can disambiguate which ones do you mean. So here's some queries that we might have looked at earlier and before, right when we were renaming some of these fields. Okay, all right. So this query, this one single query of selecting from a particular table is actually, it can be represented mathematically using the relational algebra. It's fairly more complex. It's a combination of both select and projections. Range variables. So these tables are either necessary or not, depending on whether you just have one table and you just need them if you need to disambiguate. You can rename the table so that it's more convenient for readability purposes, so that you can be a little less verbose, and you can just rename it to something that's a little easier to read. Especially useful, given a name if you need to self-join, right? If you need to have join the student table with itself, right, or the product table with itself, or the customer or the employee table with itself, because there might be some structure within the table itself. Right, so very, very useful with self-joins. We'll take a look at them a little later. So these are called aliases. So there's an alias for this for the name for that table. So it's a temporary name that you can use for in the query. There's some shorthand notations. If instead of if you are retrieving all the fields, there's some shorthands where you can just use maybe the asterisk, and that has the meaning that you're retrieving all the fields as opposed to having to list them all in the projection. Right, so you can add the alias and mean the same all the tables. If there's no ambiguity, there's no need. Right, if there's no ambiguity, there's no need to add any prefix to the fields. So let's consider a couple of tables: department and employee, and we want to be able to do some query. Over here, we are listing both tables in the from clause, right, comma separated, and some fields we're retrieving from the department, and some fields we're retrieving from the employee, right? And we are joining them here with the department ID and the ID of the employee, because the fields don't have the same names. I don't need to prepend the name of the table. But if they weren't the same, I would need to add them. Here, if you're saying select star from persons, since it's all the fields that you're asking for, and we have no where clause, we have no predicate, it would return all the records in the table, right, the whole table. Here, it returns only a subset of the fields, so it's filtering horizontally only the fields that you care about, but all the records. Select distinct. You can add the distinct keyword, and if there aren't any repeating values in the result set, it will remove those repeating values. So if you have an original table that has city, and you ask for all the cities, right, Lowell will be removed because it is repeating. The SQL defines several standard data types where the fields can be either integers, floats, small integers, numeric, bar chart, dates, and whatnot. These are some of the numerical data types. It also declares several functions that you can operate on those data types, right? So you can operate on strings like concatenation, substrings, and whatnot. You can operate on dates, extract the year, the month. You can do date comparisons. You can do date arithmetics, all sorts of things. You can also do casting and convert one data type to the next, and all major programming structures that you might expect from any programming language are also available in SQL. Here's some of the functions that allow you to convert or extract data, convert into upper or lowercase characters, or trim and remove any extra spaces, or retrieve the length of a string. You can retrieve the substring from a particular starting point and how many characters you want. You can retrieve the currently logged in user in the database, so you can make queries that are specific to that particular person, right? Who's currently logged in, right? Retrieve, if a professor goes in and wants to look at their schedule right away, you can have queries that are based on that person who's currently logged in, and retrieve only the sections and only the courses that they're teaching. Operators allow you to compare strings and regular expressions. here's a couple examples of comparing Einstein with underscore. Here matches any single character, whereas percentage matches any number of characters, including the empty. Underscore I % I underscore matches Einstein. So here's an example of using like in a select statement. In a where clause, a select statement typically we consider three major sections of a select statement. We have the select that allows it to do our projection. Our from clause allows it to do our select, right? From the from and the where kind of allows it to. It is the select statement, right? In the previous presentation, right, where we say what is the data set and what is the predicate. And now here the predicate is like, and it just shows you some other rules on how to create those predicates, those regular expressions. So here's an example of retrieving all the persons where the city is like Lowell, right? By default, it's case insensitive, but you certainly can override that in the some data types. Dates have a standard format, but there are also some formats that are specific to vendor specific on how accurate or how granular the representation of dates is, and that again you'll have to use the vendor's particular interpretation of what a date is. So you can either refer to a specific date, or you can refer to intervals between dates in weeks, days, months, years. You can retrieve you can use the current date, or extract a particular part of a date, either the month, the year, the date, the time, and whatnot, and do a date arithmetic like add intervals to a particular date. So many months, so many days. So here's some examples. I'm doing some date arithmetics. Date formats, again, depending on the vendor. Vendors might have some standard representation, but some of them are particular to their particular framework. Some of the vendors also provide lots of functions to operate on dates, like date add or subtract or data. These are from MySQL, which are somewhat different from what you might find in SQL from Microsoft. And again, each vendor will try to sell you, the use of their particular implementation of certain functionality. So here's an example of retrieving or converting between data types. Convert allows you to do casting between two data types. Here we are retrieving dates and retrieving either time or a particular day in a particular format. These formats, I believe these are SQL, SQL Server formats that either have a very condensed or more verbose representation of that date, or using military date or like European style date or for other locales. So anyway, so we talk about the select clause. Also allows you to do extend. Right, here's the extend that we saw earlier, that allows you to create brand new fields that were not there originally. Right, using the as keyword, right, allows you to create a brand new field that's calculated in terms of other fields, right, and do subtraction or whatnot. Here's a brand new field that we're creating that just has the constant value of BC. Generates this table over here. Here's an example calculating a new ID from a graduation decade from each student. So we start off with retrieving some of the basic fields from the student table, and then we can add some renaming of those fields. SID was renamed to new SID, and grad year was renamed as graduation decade. And then we can do some concatenation where we can concatenate the original SID concatenated with student number, perhaps, right? And we have a brand new value where it concatenates this literal with the original value of the SID, and we're going to store it in a new field called new SID. We can keep calculate a couple things here. We can use just arithmetic to divide the graduation year by 10, so we can calculate what decade did you graduate. And so we first divide by 10 to remove some accuracy, right? And then we multiply by 10, removing so we can calculate the decade. And then store it in graduation decade. So, for instance, we come up with you graduated in the 2000s, right, or the 2010s or the 2020s, and here's the new SID based on the original value. Case statements allow you to do kind of like on the fly logic, right, where you can on the fly calculate the values based on some if-else statements, right, that can compare certain conditions against certain possible results, and the ones that are true you can then provide the actual value that you want a particular field to evaluate to. So, for instance, here we can calculate A. Imagine that A has these very simple values A 1, 2, 3, 1, 2, 3. We can use that table from a particular test table, and we want to select the field A, right? And A can only ever have just 1, 2, or 3, right? And based on 1, 2, or 3, we can compare the value of the field A, and then the result. We can either the result can either be 1, 2, or other, and we could have used it as here and give it a name of that field. By default, it takes the name of the function that was used, right? So that's why this says case. Right? It takes a name, but here we could have overwritten it and said, in letter, maybe, in letter or written format, right? And then have this field called written format. So yeah, so you can certainly embed on-the-fly calculations. There's different syntax. This is kind of like the this is a more sophisticated version of the switched case, right? Where the case is itself an if statement, right? It has its own predicate, right? This could be any predicate in here, right? Not necessarily compared to the value A. Whereas in the switch case statement that we're familiar with, we only have one expression that is compared to a single value, right? So this expression is compared to multiple values, and then the then clause returns the value that it evaluates to. So the same example as before, rewritten, where you have case A just compared against 1, 2, or any other value. Right, so we can do arithmetic expressions where we can extract the year from the current day, from the current dates, right? And then we can subtract the graduation year, and then we can say, well, you are the alum from this particular. How many years have you been an alumni, right? How long ago did you graduate from, right? So we can calculate from the graduation year, the year against that student's graduation year. We can say, oh, you've been an alum so many years, right? For particular students. So, for instance, here we have current date is 2011, graduation year is 2007. The calculation comes back to, you've been an alum 4 years. Conditional examples here. We can take these two ideas. We can take these two ideas and from the previous query, right, where we calculated all the alums, right, and we have these values over here, right? This one tells me all the students, yes, plus how many years have they been an alumni, yes? And we store that in query 69. We can use that as an input to this other query and say, okay, well, based on that query, that I know how many years have you been an alumni, I can take the original query and then depending on the value of the how many years have you been an alumni, if it's greater than 0, right, then I know you're an alum, right? If it's less than 0, then it means that you're still in school, right? And then store that in an output table that is going to have a field called graduation status and tell you whether you're still in school or not. Okay. There's also a much more abbreviated version of this query. So instead of using the case, you can just do an actual if statement, right? If alum greater than 0, then it returns this value. It has the same syntax as Excel, right? It has if this is true, then it returns the second argument. If it's false, it returns the third argument, right? And then just renames it to be a graduation status. Right. So one of the things that we would like to consider, we'd like to introduce the. Oh, never mind. We'll come back to joins when we come back next week. We'll start joining and whatnot.